Hello everyone, I'm Sebastian Weiss. Today I'm going to tell you about infrastructure as code. We'll talk about the technologies, the tools that help us write this code, the environment design and best practices. Let's start with the definition of infrastructure as code. Wikipedia defines infrastructure as code as the process of managing and deploying infrastructure through code and software development techniques instead of interactive configuration and manual processes. In this video, we focus on the special features of infrastructure automation. What are the benefits of infrastructure automation? What challenges do we need to be aware of? We also look at various software tools that can be used to implement infrastructure as code and the categories into which these tools can be divided. And finally, I'll give you a few tips on environment design and best practices. Let's start with the advantages and challenges. The first and biggest advantage of infrastructure as code is that the infrastructure is available as code. Having the infrastructure as code not only increases visibility for infrastructure activities, it can also help to avoid knowledge silos. However, it is important to remember that infrastructure code is often somewhat more difficult to understand and is not self-documenting. It is therefore important that the infrastructure code is well documented. With infrastructure code, KISS often comes before dry. You can find these principles in the Clean Code video. As everything is now available as infrastructure source code, more people have access to it. We can therefore also integrate other aspects of our work with version control. For example, we have access to Git histories, or we can jump back to certain infrastructure versions or check who has changed something and talk to them. But the larger and more complex infrastructure code becomes, the more difficult it is to manage. Often the scaling of infrastructure becomes a problem faster than the scaling of the applications themselves. Thanks to the visibility and version control, we can now also test our infrastructure code like all other code in the CI/CD pipeline, or carry out classic code reviews. However, it is important to know that these tests and reviews can become very complex. Sometimes specialized knowledge of the infrastructure code itself, as well as the platform that the code describes, is required to perform the review or develop the necessary tests. As mentioned, infrastructure code often requires specialized knowledge and can therefore be very time and labor intensive. The advantages of automation and standardization as code mentioned so far can also help to reduce costs and direct time and manpower to other areas. If infrastructure can be easily created as code and is readily available, there may be a lot of experimentation in the early stages of the project. These experiments in themselves are very good for finding the best infrastructure, but can sometimes use very expensive resources, or they are often forgotten when the target infrastructure is taken care of. Therefore, you should take care of mitigation measures such as billing limits and alarms to be warned of high costs at an early stage. Once all the basic code has been created, new environments can be deployed in a much shorter time. This not only saves time and money, but above all, helps development, as the environments do not differ from one another. However, this also requires a sense of proportion, because depending on the complexity of the environment, the effort required to set up the infrastructure as code and the deployment processes can be very high. This can often take more time than other deployment methods, especially for rather simple workloads. If the infrastructure code and processes are standardized, we can eliminate many sources of error. It is also easier to find them with the help of deployments, code reviews, or log files. However, it can happen that in very complex infrastructures it becomes more difficult to find out whether errors are in the infrastructure code or in the infrastructure itself. Specialist knowledge of the infrastructure used is often necessary here. Infrastructure as code allows us to write automated tests that check the code. We can have security experts review our code. We can also implement secure standards and best practices in the modules we use, all before we have even deployed infrastructure. However, this trust can make it very easy to just blindly rely on it and then create new manual security problems, such as hard-coded passwords or incorrect authorizations in the code. We've heard some of the benefits and challenges of infrastructure as code. Now let's look at what tools are available and how they differ. As always, the choice of tool depends on what you want to achieve and what requirements you have. The differences can be that the infrastructure is deployed in a cloud such as AWS or in a private cloud in your own data center. Can we use standard tools or do we use our own internal developments? Are we deploying servers or configuring software that runs on these servers? All of this influences the choice of tool. This is why infrastructure as code very often does not consist of a single tool, but of several. This is because they can usually be assigned to one of two categories, which determine their intended use. There are tools that are at home in both categories. However, they have their own challenges. The two major categories are provisioning and orchestration on the one hand, and configuration management on the other. I will now introduce you to well-known representatives of both categories. First, let's take a look at the tools that are often referred to as infrastructure as code. The focus here is almost always on provisioning, that is creating and managing resources, be it virtual machines in the cloud, on-premise, networks, storage, or even users and accounts. Almost all of this can be maintained as code using these tools. The main interface here is almost always APIs from the service providers, which can be used for administration. Once a resource has been created using these tools, it always ends up directly in the tool's state file. The state file in the infrastructure as code contains the last known and deployed state of the infrastructure. The state file has several advantages for us. It enables the tool used to create a preview of all changes by calculating and displaying the difference between our code and the state stored in the state file. Since we know all the resources for which we are responsible, we can also provide a way to dismantle the entire infrastructure. Dependencies are usually also mapped in the state file, so that you can create or delete the resources in the correct order. External changes, such as the manual enlargement of a virtual machine's hard disk, are usually detected by the tools and, if they have not been restored to the code, are also undone. This can lead to problems and even unintentional data loss. Most software products in this category are declarative, that is, they focus on the what, that is, the desired end state of the resource. In other words, if the infrastructure were a destination, we would only describe our destination just like in a cab. This is called declarative. In contrast, the step-by-step instructions in a navigation device would be imperative. Declarative programming uses its very own syntax. These tools therefore often have their own syntax. There are software generators that can generate declarative code using imperative code. The best-known tools in this category are CloudFormation for AWS, Azure Resource Manager for Azure, and Terraform as a cloud and service-independent solution. All three tools are declarative. Software generators include CDK from AWS, Terraform CDK, and Pulumi. They allow the infrastructure code to be written in a classic programming language. The code is then converted into declarative code before being deployed. Next, let's look at the category of configuration management tools. These tools often require a target system to which they can connect and then execute their program code. They are therefore primarily intended for servers. On these, they configure services, install or uninstall software and users, or install updates. Some do this via an agent installed on the system, others without. In addition to configuration, they are also very often used to automate typical system administration tasks, such as the aforementioned updates or the distribution of backup scripts. Due to this different focus, it is often the case that these tools can usually only carry out rudimentary provisioning. They usually do not have the same level of status management as the tools already mentioned. These tools are a mixture of declarative and imperative, as they leave many options open to you and many things are also reminiscent of scripting. The best-known tools here are Puppet and Chef, with their client-server architecture, and Ansible and SaltStack, which do not require a central server component. With all the tools mentioned, there is no one best tool, but the choice depends on personal preferences on the one hand and on the team and environment on the other. If Python is very common knowledge in the team, then Ansible or SaltStack are a good choice. Often, however, Chef or Puppet infrastructures already exist that you would like to use. Now that we know how to provision and configure the infrastructure, let's look at what you should pay attention to when developing the code to get the best out of it for you and your team. For infrastructure design, it is very important to know what resources you have available. This is not only about the architecture of the application, but also about the budget and what knowledge is represented in the team. This can then be used to create an infrastructure strategy that perfectly supports the software architecture and can be supported by the team. In the cloud, it is often the case that the most economical architecture is chosen rather than the best one. With on-premise, it can be different because you have to do more yourself from the outset, which shifts the options somewhat and often costs more time. Cloud or managed services should therefore be preferred if the project allows it. The costs often seem very high at first glance, but when you compare them with your own time, this is often put into perspective. You should therefore always keep an eye on what can be replaced in my project or infrastructure by an external service, and preferably in such a way that this service is supported by my infrastructure as code deployment. Let's conclude the video with a few best practices for infrastructure as code. Codifying everything. Each resource and configuration should be maintained as code. This configuration represents a reliable data source for the environment. It shows which components are used, how they are configured, and how they are dependent on each other. Version control. The infrastructure should not only be available as source code, it should also be maintained in a traceable manner. Version control allows us not only to track changes over time, but also to carry out code reviews. It gives us the opportunity to collaborate better with others in the source code, thereby increasing the visibility and understanding of infrastructure changes. Test, integrate, and deploy with CI/CD. Integrate the infrastructure code into your CI/CD deployment pipelines as best you can. In other words, test it for functionality and security gaps. Deploy the code frequently. Infrastructure changes are less frequent after the initial phase of a project. Infrastructure code has the property of aging very quickly and very badly. It should therefore be deployed frequently to refresh the configuration and reality. It should always be deployed with a CI/CD pipeline and never manually. Multiple environments. Not everything can be tested easily. In infrastructure code, and especially migration paths for infrastructure, are very difficult to check. It is therefore always advisable to have more than just a production environment to be able to test such paths. Also, some resources or infrastructure components do not behave as expected. A delete recreate of a productive database after a change should not be experienced unprepared. Documentation. The infrastructure code is the source of truth for your infrastructure. Therefore, document the background for decisions and dependencies close to the code. External documentation such as wikis also have a tendency to become outdated quickly. They must not be ignored as they are very important, especially for colleagues who are not directly involved in the code. Modularization. Every infrastructure tool has a way to modularize its configuration. In Ansible, it is the roles, in Terraform modules, and in CDK functions. Modularization gives you greater control over the deployments. Modules can also be deployed and used across teams, so that a module can always be maintained by specialists, and not everyone has to be able to do everything. There are also very good public modules, roles, and templates for many things, so that you don't have to create everything yourself. However, with public modules, it is important to always be vigilant about changes. Those were the best practices for infrastructure as code. Thank you for tuning in.